Hey guys, hope everybody's doing well. We're going to transition into part two of this whole inequalities unit. We're going to break it up into two sections. We're going to talk about absolute value equations. So the first thing is we need to talk about what absolute value is and then how it will apply to equations and why. So first thing I want you to think about is what is absolute value? Absolute value, and we're going to go ahead and switch to the dot cam here as we talk about it. But absolute value is going to be distance from zero. How far from zero is a particular number? And so if we look over here at the dot cam and we say, okay, what do we got? Let's make sure we're looking at the right thing here. The absolute value of -7 versus the absolute value of 7. Well, the absolute value of -7 is the distance from 0. How far is that? Well, -7 from 0 is 7. It's distance. Distance is always going to be positive. So the absolute value of 7 is also 7. So anything that comes out of the absolute value bars is going to end up being positive because it's measuring a distance. So the absolute value of 42 versus the absolute value of -42. Both of those answers are 42. Well, let's consider how that's going to work now if the absolute value is being taken of x. The absolute value of x equals 12. That means some number inside of the absolute value bars, when it's done, equals 12. So if we think back to what we had here, what happened when I had -7 and +7? When they came out of the absolute value bars, they were both 7. So if I look at this particular problem here, and remember, x is taking the place of an unknown. Well, what can I plug in here that when I take the absolute value of it equals 12? Well, obviously, x can equal 12. But as an algebra student, we realize that there's always a little bit more behind the scenes because x can also equal -12. If I plug in 12, I get the absolute value of 12 equals 12. But if I plug in -12, I get the absolute value of -12, and that also equals 12. So let's look at this example. The absolute value of x equals 21. Take a moment, think of your answer. Now that you've got it, hopefully you realize that x equals 21, but also equals -21. All right. So we understand that there's going to be two answers when we're dealing with absolute value equations, and that's because the positive and negative version of whatever comes out of that absolute value bar can always equal 12 or 21 or whatever it might be. Now, if there's more than just an x in there, those numbers aren't going to be the same because the number inside the absolute value bars will impact it one way or the other. So let's go ahead and take a look at your notes here. And again, these notes are on your Teams page, so you can print them. There's going to be a couple really important key points as we solve absolute value equations. The first is, before we do anything, we have to isolate the absolute value bars. You have to essentially, like an equation, get them alone. Once you get them alone, you're going to get rid of the absolute value bars by creating two equations. The first equation is going to be the same. The second equation is going to be the opposite sign. So it's like we talked about before. You've got the positive and the negative version. And then you're going to solve both equations. Okay. Now, let's go ahead and see what that's going to look like. And we're going to use some examples from homework to do this. Our first example is going to be the absolute value of x minus 4 equals 2. So are the absolute value bars alone? Yes, there's nothing else there with them. Get rid of the absolute value bars by creating two equations. The first one's the same. The second one has the opposite sign for the equals. So those two equations are going to be x minus 4 equals 2. X minus 4 equals -2. So you'll notice I've got the 2 and the -2. Those are the two different equations. And now solve both. Add 4. So x equals 6. Add 4. And x equals 2. You have your two answers, x equals 6, x equals 2. Remember what I said? If there's more inside the absolute value bars, these numbers will not match. And if I test it and plug it in, I can plug these in, which you're going to want to do. And I plug in 6 minus 4 is 2, and the absolute value of 2 is negative 2. If I plug in 2, 2 minus 4 is negative 2, and the absolute value of negative 2 equals 2. So you're going to want to check your answers when you do this. And we'll explain a lot more why as we go deeper and deeper into this, and that'll be for a later lesson. All right, so go ahead and try one on your own. X plus 3 in absolute value bars equals 9. So pause the video here and try this one on your own. All right, now that you're back, let's take a look at what we've got here. The absolute value bars are alone. So let's go ahead and create the two equations. You've got the original, the one that looks exactly like what's up above it, and then you've got the one with the opposite sign. Solve both equations for x. X equals 6. And x equals negative 12. So again, make sure the absolute value bars are alone, create your two equations, and get your two answers. One final example here for absolute value equations, and that's what happens when the absolute value bars aren't alone. And we'll take a look at a couple different things when we do this. So let's take this here. Probably should have steered clear of that line a little bit there. So in the absolute value bars, x minus 1.8 minus 7 equals 3. Remember, your first step is isolate the absolute value bars. So I need to get the absolute value bars alone. So I'm going to do that by adding 7 to both sides. The minus 7 and the plus 7 will cancel out. X minus 1.8 in absolute value bars equals 10. Now create your two equations. X minus 1.8 equals 10. X minus 1.8 equals negative 10. We can, if we'd like, get rid of decimals like we did in solving equations unit. So you'd multiply by 10, and then you can solve from there. And this one isn't terribly difficult, so I'm not going to do that, but we could get rid of them if we wanted. I'm just going to add 1.8. X equals 11.8. And then I'll add 1.8 to this one. Be very careful here because I have different signs. So I'm going to have to subtract and keep the sign of the larger number. A negative 10 and a positive 1.8. The negative 10 is bigger, so I'm going to have a negative answer. And then 10 minus 1.8, because they're different signs, so I'm going to subtract, is going to give me negative 8.2. So solving absolute value equations, get the absolute value bars alone, and then create your two problems. So this is your lesson on absolute value equations. The second half of this video is going to be absolute value inequalities, which is the next lesson. So you can stop here and finish the homework assignment that goes with absolute value equations, and then come back to this video later if you need. We're going to go ahead now and go into our absolute value inequalities. Absolute value inequalities are going to start off with the same basic idea as absolute value equations. You're going to solve them the same way as an absolute value equation. You have to get the absolute value bars alone first. You're going to create your two problems. One of them is just like the original. The other one's going to have the opposite sign. Here's the one catch. With absolute value inequalities, when you write the second inequality, you will have to switch the symbol. So if it used to be a less than, the second equation, the second inequality will have a greater than. If it started off as a greater than, then the other inequality will be a less than. You also then look at the original symbol. If the original symbol is a less than or a less than or equal to, this inequality is an and. If the original symbol is a greater than or a greater than or equal to, this inequality is an OR. And that's really important to determine what kind of inequality you have. All right, so let's take a look then at an example. Absolute value, x plus 2 is less than 5. So my absolute value bars are alone, so we're in good shape. I'm going to split it up and I'm going to make two inequalities. But before we do that, I'm going to look at this symbol and decide if it's an and or if it's an or. And it's an and. So I'm going to put the word and here first. You're going to need to memorize this. This is important for the test. So let's make my two inequalities. X plus 2 is less than 5. And the second one, x plus 2, remember to switch the inequality when I make the second problem and also change the sign. So this is an and now I'm just going to solve both sides. So -2, -2, x is less than 3, and -2, -2, x is greater than -7. And if I was to graph this, this is a normal and so it's going to create the line segment in the middle. All right, and that's going to be significant as we go through and look at various problems. Let's look at one other example for our absolute value inequalities, and let's go ahead and graph this one as well. So for this example here, my absolute value bars are not alone, so let's get them alone first. So let's add 1 to both sides. Absolute value of 3x plus 2 is greater than 10. Let's make those absolute value bars a little bigger. Is this an and or is it an or? You got it, it's an or. So 3x plus 2 is greater than 10, or 3x plus 2 is less than -10. Solve both inequalities, subtract 2, divide by 3. Ran out of room here, folks. Let's just go ahead and put a little piece of paper underneath it here. Extend this on. So x is greater than 8/3. And then over here, subtract 2, subtract 2. So I'm going to graph this. We're going to remember that it's an or. Here's my 0. Here's my -4. Here's my positive 8/3. I have an open dot at -4 and an arrow to the left because x is less than. And I have an open dot at 8/3 and an arrow to the right because x is greater than. So absolute value inequalities are going to be very similar to your absolute value equations. The only difference is we're going to have to be very careful with our symbols and our signs and then the graphs at the end. We will build on absolute value equations and inequalities in the world. There will be some special case circumstances that we'll look at. But this is an intro to both, and hopefully that this helps you. And if you've got questions, be sure to bring them to our next class lesson and we'll go over them. Have a great day, guys, and I'll see you later.